your notebook out. And then there's your objective for today. So today we're going to be doing inheritance patterns. We're going to identify genotypes and phenotypes, calculate some probabilities of inherited traits using Punnett squares and family data. All right, here's your bell rigger / do now. It's a voice level 0. I'm going to set a timer for 5 minutes. Please go ahead and put this in your notebook. You do not have to write the question. I just want you to answer the prompts. 1, 2, and 3. You should be answering 1, 2, and 3. You don't need to be on the computer. All you need to do is just log in and just set your computer to the side for later. Timer is starting now. Timer is starting now. I'm going to take attendance while you're doing that. And we'll be ready to go. Voice level is what? Nate, what's the voice level?
0.
Okay, thank you. You know, where you sit is not Okay. Seconds. I'm going to come around now to start looking at what you have on your responses, and those that need it absolutely correct when you stamp, and we will talk through it, but you should be making sure you explain your answer. If you don't have any justification, then you will not receive full credit. Seconds left. What we got? Make sure you have it set. you have a lot of the information there, but it's not fluid in your justification, which is part of what this was asking you to do, right? So let's do our Punnett square now. There's no dominant here. What's listed here? Okay, let's back up. So this is free information that you should have learned. Fine, you didn't. What is heterozygous? What is it? Somebody raise their hand and tell me what it is, because that is partially why we are having a little bit of a misconception as to what should be here. You can look it up. I'll give you 10 seconds. 10, 9, 8, 7, 6, 5. Yes, Caleb. Hey.
It's a cell that.
So which one are you giving me?
For heterozygous,
Uh-huh.
it's a cell that contains two different genes.
Is it genes or alleles?
Alleles.
Okay. From each who? From who?
From
Each.
From one parent.
Each parent. So you get a dominant and you get what? Recessive. So that is what again? Everybody, that is what? I'm sorry, I can't hear you. Okay, so now what's homozygous? Go ahead and look it up. Raise your hand and tell me. Yes. I didn't forget your name. That's Ishmael. He raised his hand first. Is it one version? Homozygous is two copies, right? Of the same allele. So it can be two dominant or two what? Thank you. Two dominant or two recessive. Oh boy. So what again is heterozygous? Two versions of the allele from one from each parent. And then homozygous is going to be what? Two what? Homozygous is going to be how many copies? I just gave it to you. Two copies of the same what? Allele. Okay? So this is information. I use this bell ringer based on me being out for 6 weeks, and this was information in the packet that we should have reviewed. This is why I'm going over it again, just to stamp it so that we actually know what it is, because that is going to keep us from moving forward. Okay? All right. So now we have our Punnett square. What should be at the top of our Punnett square? It shouldn't be little t. It should be what is it called? No. What is it called? Jesus. Okay. Stop. So listen. Uppercase T is called dominant. Lowercase t is called what? All right. So what should go at the top again? Thank you. I just need the recessive. That's what I need. I don't need you to say little t, little t. I need you to say recessive or dominant. I mean, it's fine. Fine. Let's go. What's here? What goes here?
Dominant T, recessive T.
Dominant T and recessive T. Now, go ahead and finish the Punnett square now. Everybody put the Punnett square in. I'm giving you 15 seconds to fill it in. Now, if you already have this on your paper, you're good. If you don't, then you need to fill it in. 15, 14, 13, 12, 11,
Done.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. So let me just see. Thank you. Thank you. Thank you. That's not what I asked. 30 is still here. Okay. Perfect. All right. Great. So what goes here? What goes here? Dominant T, recessive T. What goes here? Somebody else, they're dead. What percentage of the offspring is gonna be short? 50%. How do we know that?
Look at the Punnett square.
Look at the Punnett square and what? Two boxes of recessive, and that represent what percent? 50%. 50%, and the whole Punnett square represents how much? All right, great. 50%. All right, cool. Perfect. Explain how you determine your answer using the allele combination. We already know that we can visually see that we have 50% of our alleles are short, but what else could we say? Somebody come up with something else to add to our justification. We know it's 50% based on our Punnett square, but what else? What can be passed? What can only be passed along here? What can only be passed along here? So if this was just heterozygous, what would be passed along here? Which alleles? Dominant and recessive. If it's short or homozygous, what is it going to be passed along as? Recessive or short. All right. Any questions? Good? All right. Moving on. Moving on. No. All right. So in your notebook. All right. Let me have your attention. It's too much chitter chatter. Ready? All right. So what you're going to do now? Explicit. You're going to look and analyze the picture. At your groups, I'm going to give you 1 minute to look at the picture and analyze and describe some common traits that you see present, and then you're going to infer the characteristics from the mother and father based on this given picture. I'm not going to tell you whether the cat is the mother or the father. You're inferring. 1 minute, talking with your group. Turn and talk. And are we ready? And go.
Hey, that's father? Because I don't catch. Yes, I can catch. She asked me a question because I don't like cats.